Hello everyone to the fifth video for our Redstone guide tutorial. In this one we're going to be talking about a circuit that uses multiple gates together for a single output and a flip-flop switch. So let's take a look at our first object, which is the multiple gate circuit. So we've got an AND gate, we've got a simple input going to a second AND gate, and then we've got a NOT gate going to our output, which is a redstone lamp. So let's reset this so that they're all off. Let's take a quick look at our truth table here. So we've got input A, B, and C. And that means input A, input B, and our input C. And we have our output, which is our redstone lamp. And so when we look at this truth table, we can see that if they're all off, the output's on. If only input B is on, the output's on. Input C is on, the output's on. And that, for the most part, almost at all points is the output on. And the only way to get the output off is to have all three things turned on. And so we can tell that this is pretty much just two AND gates. You know, we want to have this and this and this to make the change to the output. Any other combination that does not have input A and input B and input C on at the same time does not change the output from its normal base state. So let's test that out. So we have input A, we turn it on, and there's no output because this is an AND gate, and we want to have input A and B on to provide our output going to this guy. Now we still don't have any output from this gate because input C is still off. So let's turn that on, and we see that now our redstone lamp is off. We're providing power out to the NOT gate, and then the NOT gate is powered off because it has power going in. So that is our multiple gate circuit. And you can change out any type of gates. You can do ORs, you can do ANDs, you can do NORs, you can do anything you want to do, as long as you just keep tying their outputs into the inputs of the next one. Alright, now next object is called an SR latch, and this is a whole different idea from just having different gates applying their outputs to another gate, because an SR latch gate is two OR gates with their inputs tied to the outputs. So that's a little bit confusing, but let's talk about what this is first. So an SR latch gate is called a set and reset latch gate. A latch gate means that at some point, at all points, there's always power being provided to one or the other outputs. So we have not Q output, and we have Q output. And now what we're usually doing in electronics is we're looking for that Q output. And we provide the not Q output for various tasks later on in computational electronics. But all we really care about in Minecraft right now is getting Q to turn on. And so a latch gate is basically something that you can use with any kind of a power source that says if that power source is turned on, then Q is set, and Q is set to on. And it doesn't matter if I keep jumping up and down, turning on, flicking the switch, doing whatever I do, as long as I've pushed the set input once, Q is always on. And the only way to get Q to turn back off is to reset it. And so now I reset it, and it doesn't matter how many times I reset, Q will always stay off. And the only way to turn Q back on is to come back over and set it again. And so we see there's always power going in this circuit. There's always some power, but there's only ever one output that's on at a time. So let's look at how this works. So like I said, it's two OR gates, and it looks a little bit strange, but let's look at our first OR gate, which is the set gate. So this is our input A for the OR gate. It's right here. And then our input B is this. It's coming over, and it's coming from the output from the other OR gate. So our output coming over here. And so our output is like it's tied together from into the input of this OR gate. So we see, oh, okay, so even though this switch is off, this switch isn't doing anything, there's no power being supplied by it, there's always power being provided because this output's on. So it's power coming over, and it's our OR gate, so it's powering off this NOT gate. So it's two OR gates. It's really actually two NOR gates. It's two OR gates with NOT gates on the outputs, as you can see. Power coming in, done. So it's an OR gate going out to a NOT, and taking that output not only to power the output object, but to also tie back into the input of the other OR gate. And you can see it's the same thing here. I have the output from here going into the second input for our OR gate here. So now let's look at the truth table. So we can see this truth table does not look like our normal truth table with just inputs and outputs. Instead, this truth table is about actions. So what happens when I do this or that? So we have the set action, we have the reset action, and then we have what's going to happen. So if set and reset are both 0, then we have an invalid state, because it's impossible, if this circuit is set up properly, for one of these, or for both of these to be powered off, because we're always supplying power from the other side. So no matter what I do, there's always power being put into one of the gates. So that is why 0, 0 is an invalid state. And if you have 0, 0, somehow on your circuit you do not have a working latch gate. It is broken. It just needs to be fixed. Alright, so now set is 0, and we push the reset button to turn the reset button on. The action is that Q is set to 0. So no matter what we do, as long as we push reset and the set button's not on, Q is always 0. Does not matter what else is going on, Q will always be 0 as long as you're pushing the reset button. Now set, if it's 1 and nobody's pushing the reset button, it will change Q to 1. It will always set Q to be on. So it doesn't matter what I'm doing, Q is always on once I've pushed that button. So that's the idea, set and reset. You know, turn it off, turn it on, turn it off, turn it on. Now, if you somehow set up a situation where set and reset are both being powered, what would really happen in the real world with a real SR latch gate would be that there'd be no change to Q. So if Q is on and you have both of these powered on, Q would stay on. If Q is off and you then set both of these to on, Q would stay off. So what happens in Minecraft, though, unfortunately, is that if both of these are powered on at the same time, so let's take a little switch here, and we're going to tie it on over, and you see it starts blinking, and eventually it shuts down. This is the sign that your Minecraft circuit is broken. It starts going crazy. So let's stop that. Now we got break it from there. Alright, so that's what happens if you try to provide power to everything. It just will start blinking and going crazy, and if you set up a loop or something where it's going to try and turn itself on and off too much, Minecraft, the server itself, will actually stop all power to that circuit, and you have to, turn it back on or off somehow. But yeah, so in Minecraft, what happens is this breaks. It's basically an invalid state also. In the real world, you would see no change to Q in case somebody pushed both buttons at once. So this is a really, really useful little latch gate to know, because it can be used for all sorts of things. Whether you want to control a railroad system with this and say, hey, if I'm telling the railroad to go one direction, I want to make sure that another switch changes somewhere else. You can use this for things like the puzzle I created for the secret shop last week, where I had to make it so all four pressure plates had to be on before it would open up the door, and then I was using a reset circuit to turn all of them off at the same time and close the doors after a little bit of time. So that's what this was used for just recently in the world. You guys just didn't really see it, you just knew it was a puzzle, but you didn't really understand how the puzzle was working out underground. So play around with this if you have some time and experiment with it, and just see what you can do. And if you think it's really cool, show me a video. Put up a video on YouTube or leave a comment telling me about what cool thing you made that uses an SR latch gate. And we'll talk more about more gates and other latch types next time. Alright, I'll see you guys later.